Hello dear student, welcome in the online lecture series. I am Dr. Balasaheb Pagar, working as a associate professor in chemistry. Srimati Vimlaben Khimji Tejukaya, Arts, Science and Commerce College, Deodel Camp. Dear student, in the previous lecture we discussed about the alkyl halides as well as the aryl halides. Preparation and the reactions of aryl halides discussed in the previous lecture. Aryl halides or alkyl halides undergo a substitution reaction, electrophilic substitution reaction, means SN1 reaction, SN2 reaction, SNI reaction, and the substitution versus elimination, all these points discussed in the previous lecture. Today we start a new topic, that is aldehydes and ketones. So in case of aldehyde, what is meant by aldehyde? Aldehydes are the organic compound that containing a carbonyl carbon. Introduction of the aldehyde, nomenclature of the aldehyde, preparation and reactions of the aldehyde. So in the today's lecture we discuss about all these points. Aldehydes and ketones having a general formula, means the carbonyl carbon that is present in the alkane, means one of the carbon atom of the alkane which is in the form of carbonyl carbon. So if the carbonyl carbon both side attach the R groups, that is known as a ketone, and if the carbonyl carbon one side attach R group and another there is a hydrogen, that is known as a aldehyde. So aldehydes nothing but the RCHO, and the ketones that is nothing but the RCOR. Nomenclature of aldehydes and the ketones. So student must be learn all these points. So aldehydes and ketones are the oxygen analog of the alkanes. Oxygen analog of the alkenes, means in the alkene there is a one site of unsaturation, and in aldehydes or ketone there is also one site of unsaturation. So general formula CnH2nO, also called as the carbonyl compounds because there is a presence of carbonyl carbon. Aldehydes contain at least one hydrogen atom which is attached to the carbonyl carbon, and in case of the ketone both side there is a R groups present on the carbonyl carbon. For example, carbonyl carbon means the carbon oxygen double bond. On this oxygen there is a two lone pair of the electrons. Aldehyde general formula RCOH, and the ketone general formula RCOR. Carbon is a sp2 hybridized. In case of the alkenes there is also the hybridization is sp2, and in case of the aldehydes and ketone there is also the hybridization of carbonyl carbon is sp2. Carbon oxygen double bond is a shorter because the oxygen is more electronegative as compared to the carbon. So bond length in case of the carbon oxygen double bond is a shorter as compared to the carbon carbon double bond because oxygen is more electronegative than the carbon. So attract more strongly and then the bond becomes shorter, and the bond is shorter, that's why the energy is also more. Means the carbonyl carbon is a more stronger bond as compared to the carbon carbon double bond, and the reactivity of this carbonyl carbon also depends upon the nature of oxygen. So oxygen is more electronegative as compared to the carbon, that's why on the oxygen there is a delta negative charge and on the carbon there is a delta positive charge. Aldehydes and ketones reacts with nucleophiles. So carbonyl carbon is the electron deficient nature, that's why that reacts with a nucleophile. So nucleophilic addition takes place across a carbonyl carbon. As the number of R group around the carbonyl carbon increases, the reactivity of carbonyl carbon decreases because the R group that having the electron donating effect, means inductive effect, donate electron through the inductive effect, or if there is a heteroatom or if there is a carbon carbon double bond, maybe donate electron through the resonance effect. Means if carbonyl carbon attach with a more R groups, the reactivity of that carbonyl carbon decreases. For example, in case of the formaldehyde, there is a 2 hydrogen atoms attached to the carbonyl carbon. In case of the aldehyde, there is a 1 hydrogen atom which is replaced by the R group, and in case of ketone, there is a both R groups. So effect of the R group is electron donor. That's why the formaldehyde is more reactive as compared to the aldehyde, and again aldehyde more reactive as compared to the ketone. IPC nomenclature system of the aldehydes or the ketones. So aldehydes IPC nomenclature. So E from the alkane which is replaced by the Al, means the last word E which is replaced by a Al, and in case of the ketone, the last word E which is replaced by a ONE. The aldehyde carbon is numbered 1. So numbering must be start from a carbonyl carbon in case of a aldehyde. Means aldehyde carbonyl carbon that must be present at a terminal position, and numbering must be start from a carbonyl carbon. If the CHO is attached to the ring, use the suffix carbaldehyde. Means if there is a presence of a ring and on that ring there is a CHO group, then suffix use that is a carbaldehyde. For example, carbonyl carbon, then CH2, CH double bond, CH3, CH2, CH3. So numbering must be start from carbonyl carbon. So the CH3 group which is attached at a 3 position, that's why name of this compound is a 3-methyl pentanol, and there is a 5 carbon, that's why pentane E replaced by a Al, pentanol. So 3-methyl pentanol. Another example, here the CHO group which is attached on a ring. So the position of the ring is at a 2 position. 2-cyclopentene means the carbon-carbon double bond in the ring that present at a 2 position. So 2-cyclopentene carbaldehyde. So last word which is replaced by a carbaldehyde. Use of a common name systems. In case of common name system, and if we compare with a acid, so last word acid IC which is replaced by a aldehyde, For example, in case of a formic acid, the name of that compound is formaldehyde, common name of this compound is formaldehyde, and if there is a 2 carbon atoms, the common name of that compound is a acetic acid, then acetaldehyde, or propanic acid, propanaldehyde, or the 4 carbon atom means butyric acid, the name of the common name of that compound is a butyraldehyde. So common name of the aldehyde which is compare with a acid, and last word which is replaced by a aldehyde, means IC which is replaced by a aldehyde. Then IPC nomenclature of the ketones. In case of ketone, last word in case of alkane E replaced by a ONE. Indicate the position of carbonyl carbon with a number. Means in case of ketone, the carbonyl carbon may be present at a 2 position or 3 position or like this. So numbering must be start from a lower side, means from that side there is a carbonyl carbon. Number the chain so that the carbonyl carbon has a lowest possible number. The cyclic ketones, the carbonyl carbon is a assigned the number 1. For example, in case of a cyclobutanone or in case of a cyclohexanone, that carbonyl carbon has a number 1, means consider that carbonyl carbon is a number 1. For example, CH3, CO, CH, CH3 and CH3. So in this case, in this straight chain there is a 4 carbon atoms. At a 2 position there is a carbonyl carbon, and at a 3 position there is a methyl. So 3 methyl, and how many carbon atoms present in this straight chain? 4. So butane means butanone. Last word E replaced by a ONE. So 3 methyl 2 butanone. Another example, carbonyl carbon which is present in a cyclic ring. So number the carbonyl carbon, that is a 1. So the position of bromine with respect to carbonyl carbon is a 3. That's why 3 bromo cyclohexanone. Another example, in the straight chain there is a 4 carbon atoms, means the butane, means last word butanone. And at a carbon number 4 there is a hydroxy, so 4 hydroxy, and at a 3 position there is a methyl, 4 hydroxy 3 methyl, 2 butanone. Common names of the ketone. Common names of the ketone, which is maybe by using a methyl groups or by using a alpha, beta, gamma like a number. For example, in this carbon-carbon there is a one side attached with a methyl group and another side there is a isopropyl group. So methyl isopropyl ketone. Another common name alpha, so bromine which is attached at a alpha position, that's why alpha bromo ethyl isopropyl ketone. Some of the ketones that having a historical names, for example acetone, acetophenone, benzophenone, all these compounds having a historical names, means those scientists discovered such type of the compound, that scientist naming the compound, that is for example acetone, acetophenone and benzophenone. Then the physical properties of the aldehydes and ketones. So in the aldehydes and ketones there is a carbonyl carbon, means the boiling point of the aldehydes and ketone which is higher as compared to the alkane, because the alkanes are non-polar while the carbonyl carbons are the polar. That's why there is a more attraction, means if we compare with a alkane, saturated alkane having a comparable molecular weight, then boiling point of a aldehydes and ketones is higher as compared to the alkanes. But the boiling points of the carbonyl carbon which is less as compared to the alcohol, because in case of alcohol there is a hydrogen atom which is present on a oxygen, so there is a OH group, that's why there is a formation of hydrogen bond. Means if we compare the boiling point of aldehydes and ketones with a alcohol, the alcohols having a higher boiling point as compared to the ketones, because in case of alcohol there is a formation of hydrogen bond. For example, butane, boiling point of the butane is a 0 degree Celsius, while the boiling point of the methoxyethylene means ether, that is a 8 degree Celsius, while the boiling point of the propanol, that is a 49 degree Celsius, means the boiling point of propanol is higher as compared to the aldehyde or the butane, means the alkane. And the boiling point of the aldehyde or ketone, if we compare with the alcohol, nearly same molecular weight, for example 1 propanol, so boiling point of the 1 propanol is a 97 degree Celsius. The boiling point of the propanol is higher as compared to the aldehydes and ketones, because in a propanol there is a formation of a hydrogen bonding, and strong hydrogen bonding, maybe intramolecular or intermolecular hydrogen bonding. Solubility, good solvent, means it aldehydes and ketones which is highly soluble in the organic solvents like alcohol or benzene. Lone pair of a electrons on a oxygen of a carbonyl carbon that accept a hydrogen bond, means there is formation of a hydrogen bond with a water molecule or the hydrogen bond with a NH. So acetone and the acetaldehyde are miscible, means lower aldehydes and ketones are highly miscible in the water, because there is formation of a hydrogen bonding, while the other aldehydes and ketones which are less soluble in the water, means immiscible in the water but soluble in the organic solvents. Then the next point, that is a laboratory preparation of the aldehydes and ketones. So aldehydes and ketones that having a carbonyl carbon, so carbonyl carbon which is easily synthesized by using the alcohol, easily synthesized by using a carbon-carbon double bond, or easily synthesized by using a acid chlorides, first from the alcohol. So primary alcohols if oxidized by using a oxidizing agent, then that convert the alcohol into the corresponding aldehyde. And the secondary alcohols if we oxidize by using oxidizing agent, that convert into the ketone. So primary alcohols on control reaction with a K2Cr2O7 in presence of dilute H2SO4, that gives the primary alcohol that reacts with oxidizing agent and convert into the aldehyde. This reaction is not stopped at the aldehyde stage, so further oxidation also possible in presence of a same catalyst, and then further convert into the corresponding acid. Means here the reaction not stop actually at the aldehyde stage. when the oxidation carried out in presence of a strong oxidizing agent further oxidize to the carboxylic acid. Means aldehydes are also oxidizable compound that easily convert into the corresponding carboxylic acid. So another reagent, that is a pyridinium chlorochromate, PCC. It is a most useful agent, and by using this reagent, if we oxidize primary alcohols that convert into the aldehydes, and further that is not convert into the acid. So by using the PCC is the specific reagent, the reactions stop at the aldehyde stage and not further convert into the acid. For example, 1-propanol on reaction with a pyridinium chlorochromate that convert into the propanaldehyde, and reaction stop at a propanaldehyde. Further, there is not convert into the propanoic acid. Then second laboratory preparation from acid chlorides by using a Rosenmund catalyst or the Rosenmund reduction. Acids are difficult to reduce. The first convert into the acid chlorides. So acid carboxylic acids easily convert into the acid chlorides by using a different types of the reagent, means phosphorus in presence of halogen or the PoCl3 or SoCl2 easily convert into the acid chlorides. So acid chlorides on reduction with hydrogen in presence of a barium sulfate, or the strong reducing agent, that is a lithium aluminum hydride, or the that reacts with a acid chlorides and convert into the corresponding aldehyde. So reaction stop at a aldehyde stage. So Rosenmund reduction, acid first convert into the acid chloride, and then acid chloride on reaction with barium sulfate in presence of palladium hydrogen and convert into the aldehyde. Or the another example, para-nitrobenzyl chloride on reaction with lithium aluminum hydride, and then that also reduces the carbonyl Cl into the COH. Another laboratory preparation, that is from the phenols. So phenols on the reaction with a reagent by using a Riemer-Tiemann reaction. So Riemer-Tiemann reaction is specially useful for the introduction of a carbonyl carbon or introduction of a aldehyde CHO at a ortho position with respect to the OH group. So phenol on reaction with chloroform in presence of a aqueous NaOH forms a ortho substituted aldehyde. So here there is a formation of only the ortho product. So chloroform in presence of NaOH, first there is formation of a complex compound, means first formation of a unstable molecule, that is a CHCl, means one of the chlorine atom which is replaced by a hydrogen, and then that convert into the dihydride, means geminal hydroxide, and geminal hydroxide which is converted into the aldehydes, and after hydrolysis gives the salicylic acid. So this reaction is useful for the introduction of a aldehyde group ortho with respect to the OH group. And if the both ortho positions are blocked, then reaction takes place at a para position, because the OH group is a ortho para directing, and if the ortho positions are blocked, then reaction takes place at a para position. So student must be solve following questions. What are ketones? Give the general formula of ketone. So what are aldehydes? Give the synthesis of benzaldehyde from benzyl chloride, means the Rosenmund reduction. Boiling point of a aldehyde and ketones higher than the alkanes of a comparable molecular weight. So why boiling point of a aldehydes and ketones are higher than the alkanes? Because in alkane there is a only carbon hydrogen, and in case of a aldehydes and ketones there is a carbonyl carbon. So carbonyl carbon is the polar, that's why there is a more interaction, and because of a polar nature, boiling point of a aldehydes and ketones are higher as compared to the comparable molecular weight of a alkane. So in the next lecture we discuss about the synthesis of ketones as well as the reactions of aldehydes and ketones. So today we stop here. Thank you very much.